Hi, everyone, and welcome to How to Scale Business Intelligence on Your Lakehouse using a semantic layer. And my name is Dave Mariani. I'm the CTO and co-founder of AtScale. So today we're going to be diving into just what a semantic layer is and how it works on a lakehouse. And I'll also be coupling this with a live demo so you can actually see how a semantic layer works on a Databricks lakehouse. So let's get started. Well, first of all, before we get too far, let's just talk about what a semantic layer is. This is a great definition that you can get right off of Wikipedia if you do a search in Google for semantic layer. And what I like about this is that it's a pretty concise and real accurate description of what a semantic layer is and does. First of all, it's a business representation of corporate data. So it's a business representation of data. And that's really key because it means it's business friendly. So we're not talking about a technical view of data. We're talking about a business friendly view of data. The other key word there is autonomously, and allowing end users to access data autonomously. That means self-service because users can get access to that data with in a business-friendly way without being overly technical. And then finally, common business terms. So that's really important because that's metadata. So we're going to be talking about revenue and gross margin, not about tables and columns and schemas and joins. So a semantic layer, in short, it's a logical business-friendly view on top of your data. So what's the value of a semantic layer to an organization like yours? Well, traditionally, semantic layers have lived in a couple different places. In the very beginning of the BI platform market, the semantic layer was tightly coupled with visualization or reporting. So you had a semantic layer for Tableau, and you had a semantic layer for Power BI. You had a semantic layer for Looker. You had the semantic layer for your Jupyter notebooks. So everybody had their own definitions embedded in the front end of what a semantic layer was and what the business definitions of the business metrics were. You also could have the semantic layer living in the data platforms themselves in the form of like reporting views or the like. Now, neither of those are really great, and they're not great options because, if you have multiple data platforms or multiple data sources, then you're going to have problems there. If you have multiple BI tools, if you have different groups like a data scientist and a business analyst, you're also going to have troubles because you're not going to have consistency of definitions across those different groups. It's also going to be very difficult to control access to data because now you have a bunch of inbound queries and inbound query users who are all going to be asking questions differently of data using different tools. And you also potentially have different data sources with people to access, making it really difficult to apply governance consistently. And then when you want to display or you want to share new data assets with your consumers, you also have a problem of having to go through the traditional data pipeline process, which is lengthy, time consuming, and costly. With a semantic layer, which is built on data virtualization, you can deliver new data to the business that's consumable day one, and you can do it very quickly because you can avoid a lot of the work that you need to do with traditional data pipelines. So where does a semantic layer fit in the modern data stack? Well, you can see it fits really in between your data consumers and your databases or your data platforms. So let's just talk a little bit about the data consumers first. Well, there's three different categories of data consumers. There's your business users who are typically using BI tools like Tableau and Power BI and Looker. You have your data scientists who are using Jupyter notebooks or Auto ML platforms. And you have your application developers who are typically using code to query databases to build their data and analytics into their applications. So it's really important for a semantic layer to be able to address those three different personas. And it turns out that those different toolings require really different types of protocols to access that semantic layer. So it's not a one size fit all. It's not just SQL that's appropriate here, because while SQL is a very common language, it's not so great when you're looking at Excel live connectivity or you're looking at Power BI access. It's not great if you want to write Python, and it actually may work if you want to write an application, but not if you want to be able to use metadata in a very business-friendly, multi-dimensional kind of way. So then on the bottom side, you have cloud data warehouses out there. You have data lakes like our Lakehouse. You have SaaS applications, all with schemas, all with lots of data, and making it very difficult for users without a semantic layer to find the data they need. So a semantic layer, by presenting that logical view to those data consumers, can hide all the complexity of where the data is and where it lives. It also gives the organization the freedom to change things around in the future. Because we have a tightly coupled consumption to the platform, you're able to move things around and introduce new data platforms or introduce new data consumers without having to reinvent the entire wheel. You notice that the enterprise data catalog runs along the side there. Really important for the semantic layer to share its metadata with the data catalog so that the semantic layer is searchable and findable through the enterprise data catalog. So it's a really important, great relationship and important in the entire ecosystem. So now we know where the semantic layer sort of fits into the stack. Let's talk a little bit about what a semantic layer needs to do. Well, a semantic layer, these are sort of like the really core requirements for a semantic layer to really be something that can do the job. Well, first of all, it needs to support live connections to data. So if it's not live, then the semantic layer is not going to work because people are going to have to import data to go around it, and that means you lost control of that data and you lost control of the semantics. So it needs to be live. On the bottom half side, it needs to connect to a variety of different data platforms, and it needs to leverage their native capabilities. That means it needs to be dialect aware. So a one-size-fits-all does not work because we need to make sure that we can push down all that compute to the underlying data platform so it can do its job, like the Databricks Lakehouse. So in the middle, you got some core functionality that you got to deliver, including the ability to create a semantic model, including the ability to access data virtually through those push-down queries, the ability to express the business using dimensional analysis, as well as optimize queries for performance so that you can maintain that live connection without having to wait minutes or even hours to get your data. And then finally, it needs to be able to apply row level security and object level security and masking live at query time using the metadata and the semantics defined in that semantic model. So now that we know what the core capabilities of a semantic layer are, let's talk a little bit about what it looks like. Well, there's really kind of two personas that are involved in a semantic layer implementation. The first persona is really the data steward, and we're going to be talking a little bit more about this in a few minutes when we talk about concepts like data mesh. But a data steward is responsible for modeling the data. So one of the challenges that we have with the modern data stack is that if you force your consumers to go straight against the raw data, even if you have reporting views, it still is difficult to access because they have to understand SQL and understand how to model that data using SQL. So what a data steward will do with in this case, this is AtScale Design Center, is that they should be able to create a logical view of that data and do that physical mapping on behalf of their consumers. So the data steward is someone who is a little bit more experienced, who understands where the data is physically, as well as what the business terms mean. And they're actually creating those connections. So they're building that logical view of the data you see on the right hand of the screen here in this panel. And they're able to do that by visually creating relationships and creating hierarchies, metrics, and dimensions so that they can be consumed downstream. And it means that the semantic layer needs to be able to express fully the business. So it means it needs to be able to handle complex expressions, multi-pass expressions, to be able to do things like ratios and to do non-additive measures. So it needs to be really, really pretty sophisticated, again, or else you're kind of stuck and you're not able to express the business, then no one's going to use your semantic layer. And it needs to be providing virtual data access. That means you need to be able to connect to your data platforms like a Databricks Lakehouse and be able to model that data in place without any additional data movement or data extracts. So now that we know what it looks like to a data steward, the data steward is basically doing that sort of preparation on behalf of the data consumers. Well, what does the semantic layer look like to a data consumer? Well, you can see over here on the left is, again, an example of what you saw there in the previous screenshot, where we've actually defined a semantic layer. We defined a model. So we begin with a semantic model. And then you can see that on your right, we can see just a few examples of what that semantic model would look like to a consumer connecting live. So again, this is not a data extract, we're connecting live. And so in Tableau, you're going to query using the SQL protocol against the semantic layer. In Excel, you're going to be communicating with MDX because that's its native language that it talks to for fetching data for pivot tables and cube functions. And you have Power BI who wants to speak DAX. And of course, you have Jupyter Notebooks and AutoML platforms that want to speak Python. So the semantic layer will work across all these different protocols. And that's what I mean when I say SQL is not enough. You need to be able to be expressive and need to be able to handle multiple inbound protocols in order to answer all the questions from all the different tools that consumers want to use. So the key with the semantic layer is you're not forcing your consumers to consume in only one way. You're really taking the data to them and to the tools that they already know and love and know how to use and are exceptional at. So by doing so, by giving them a business-friendly language like you see here, which allows them to sort of skip that whole step of having to model it themselves, and by them being able to use a tool that they have expertise in, you can see that a lot more people can get access to data. Actually, for the data lakehouse with the semantic layer, with the AtScale semantic layer, you can have every Excel user be a data user and make data-driven decisions using Microsoft Excel live against the Databricks Lakehouse. So let's just talk about a use case. So a lot of times a semantic layer is used to migrate OLAP type of workloads. Let's say SQL Server Analysis Services, for example, or Cognos or Business Objects, and you want to get rid of those old platforms, but you don't want to get rid of the functionality that those end users have been using and reliant on for so many years. So a typical use case for a semantic layer is to modernize those OLAP workloads and bring them to the cloud and bring them to a lakehouse like a Databricks Lakehouse. Another use case, which I want to talk about for a minute, is a data mesh use case. So if you're familiar with data mesh is not a technology. It's really an organizational style. And it's a method of pushing down responsibility for creating data products to the actual business units or domain teams themselves. So rather than having a centralized data team responsible for doing the work and creating data products, you're allowed to decentralize that, get a lot more scalability by allowing these different data domains to actually create their own data products. Now, a semantic layer is excellent and as I think a required tool for delivering a common language for a data mesh style of architecture. And so what you see here on the screen is that you see I have three different domain teams: marketing, sales, and finance. And I also still have a data team. And the data team is, data team is responsible for, for tool selection, for, in this case, they're going to manage the semantic layer platform itself, and its usage. They're going to potentially create some common data pipelines for these data domain teams to leverage. But a semantic layer is really important from a modeling perspective. So say, for example, time. If you're in retail, you know that a time calendar, a date calendar is not so simple. It's not just months and quarters because you have reporting periods for holidays and the like. And so it's really important for everyone to be able to speak the same language of time, which means everybody rolls up data the same in the same type of buckets. So, for example, in this example, you may have a central data team responsible for creating a time dimension. Now, this is what we call a conformed time dimension or a conformed dimension. This is where it's really important for the semantic layer to be multidimensional aware, because now if you can share that time dimension, you can allow your marketing team to create their own dimensions. So let's say the marketing team obviously owns marketing campaigns, so they may be the data steward for the campaign dimension. And with the campaign dimension, they can combine their campaigns with the time dimension and create a campaign model. So with a campaign model, now they're the data steward and they're the owners of that. And of course, others can use those campaign models to do analysis without having to understand everything that the marketers are doing. Now, the sales team may create sales ops models, and they may consume that time dimension. And you may have the finance team who creates their cost models, and they may be able to also get access to that time dimension. So now that we have sort of three different models here in this example, a sales ops model and a campaign model and a cost model. So if we have a common semantic layer platform managing all this, now, for example, we can create a combined model by combining the campaign model and the cost model to then create a campaign ROI model. So just like Lego building blocks, we can click these together. And then just like a good programmer loves encapsulation and abstraction, the semantic model provides that same capability of abstracting away the details and encapsulating all the business logic within these models. So this is excellent for data mesh because now the different domain owners can control what they know and what they understand, be able to encapsulate those in the form of common conformed dimensions that they can share, as well as full built models that they can share. And other teams can link those models together to create all new mashups and new views of the business without having to understand each other's domain. So this is a really a great use case for a semantic model is if you're looking at decentralizing your analytics data product creation, I really suggest that you really look closely at a semantic layer platform because that's going to really be the glue that allows you to really decentralize without creating chaos and inconsistency and getting right back to where we were before where it's a free-for-all and everybody's speaking their own language. So how does a semantic layer get deployed? Well, you can see here in our Databricks medallion architecture, we have bronze, silver, and gold. And Databricks and the Delta Lake is excellent for being able to allow you to quickly create those transformations and to be able to create those different levels of data. So where the semantic layer fits in, this is a picture of what AtScale is. It fits in between the data lake and the consumers. So now the semantic layer, as you can see over here on the right, you can see that the different tools are connecting and talking to the semantic layer using their respective protocols. The AtScale semantic layer is then translating the logical view of that data, so they're logical queries, with the protocols of those queries and translating them into Databricks SQL, which then runs against Databricks and the Databricks Gold layer. Now, as it does that, it also recognizes common query patterns and creates AtScale aggregates, their delta tables, in the Delta Lake and in the Databricks Lakehouse. So we like to think of that as almost like a diamond layer, where now you have a set of aggregates that are being created autonomously based on query behavior, and the semantic layer platform is using those aggregates wherever possible to make queries very fast. So that's really the key. The semantic layer needs to do performance management in addition to being able to express the business to create a business-friendly layer. In addition, it needs to speak many languages to allow everybody to play. So given that, what I thought I would do in the remaining minutes is spend some time on showing you what a semantic layer looks like in practice and live. So let's do that. I'm going to stop slides for a second, and I'm going to come to, in this case, I'm going to show you what an AtScale semantic layer looks like. And what you're looking at right now is the AtScale Design Center console. So this is, again, where the data steward creates the semantic model. You can see I have a preview panel over here. I have a model called Internet Sales. And you can see I have different folders and different hierarchies of data, all within my semantic model. This is the view that the users or data consumers are going to see. And you can see on the right is I have relationships represented by the orange lines, and I have these entities. The blue are just raw tables out of Delta Lake, and the greens are actually models or conformed dimensions that have been shared with from a common library from other data stewards. So let's go ahead and let's create a new model, and I'm going to call this my Databricks Lakehouse store. And I'm going to go ahead and enter my model in Canvas here, and I'm going to start to add some data. So I'm going to come to my data sources panel here, and I'm going to look at my Databricks cluster here, and you can see I have a bunch of different catalogs. So we're all Unity catalog friendly here. You can see I have a bunch of different databases and then schemas with my raw data. I'm going to start with a sales log, and sales log is just a table in Databricks. If I double click it, I could see and do a preview and see what's in there. It's a table that has all my sales data, and it's my sales data that cuts across, has every single SKU and order in it, and you can see it's very much raw data here. So it's probably this might be a little silver, maybe a little gold. But what I'm going to do is I'm going to do some transformations for this data. I can see in this product info field I have some nulls in it. I can, for example, replace those nulls right in place with a transform, changing nulls, for example, into unknowns. Now you can see over here I have a new column, and I could use that new column. You can see it's now transformed, and I can then name it whatever I want and use it instead of the source column. I can also create new calculations, which I'm going to do right now. I'm going to create a sales tax, and I'm going to compute that sales tax times by just multiplying it times 8.5% here. Now, what did I just do there? So what I did is I actually created a snippet of SQL. Now, this is Databricks SQL. So that means I can do anything that Databricks SQL allows me to do when I create a calculation in the semantic layer. That's really important because, again, we're going to push those down. You can see now I have my sales tax column here. And that means anything that Databricks can do, the semantic layer model can do. And that's really key. So now you see I have a sales tax here in this is a data set now. Now this becomes a shareable entity right now. And that means I can share this data set called sales log with other data stewards, and they're all going to be able to get that sales tax calculation for free. I'm going to go ahead and just put it and create it as a measure in this model I'm creating. I'm going to put it into a folder called sales metrics. And if you see in my preview panel, if I click back there, you can see I have my first metric called sales tax. I definitely want to understand how many items of each SKU people are ordering. So I'm going to do my order quantity. I'm going to put that into a folder. I definitely want to understand exactly how much people are spending for each purchase. So I'm going to do the sales amount. And now I have my first three metrics. Okay, so what's next? Well, I'm obviously going to want to cut this data by time. I'm going to look at it by customer. I want to look at it by customer location. I'm going to look at it by product type. And for that, I'm going to take a shortcut here because I'm going to go into my library, and I'm going to go into my conform dimension library, and I'm going to pull on my customer dimension. I'm going to pull on my product dimension. I'm going to pull on my date dimension. Because I'm a retailer. And you can see I have a retail 445 hierarchy all set and ready to go. So now what I just did here is I just used from the data steward, another data steward. It could have been, I could have created these dimensions, conform dimensions myself, or they could have come from a centralized data team. But I know that if I go ahead and link this up, and this is how I use it. I'm going to go customer key. I'm going to link it up to the customer dimension, which is going to create this relationship between sales log and my customer dimension here. And look what happened. What I got was I got all this information for free. So I got a bunch of customer information along with their locations that I can roll up by city, state, country, or by zip code and country. So I got all that because if I double click on customer dimension, you can see that the customer dimension is made up of its own model. So I have models embedded here. That in this model, customer dimension also includes a geography dimension, which is itself a model. You can also see that I'm having a user filter by location. So this is an example of a row level filter that's tied to this model. So yes, I have 4 different tables in my Databricks Lakehouse to actually construct these 2 different hierarchies. And I also have the ability now to restrict my access based on my users or query users location. And because I've actually embedded that in my model, it means that anybody who, any user, any data steward who uses that customer dimension model is going to get that same logic and that same governance. So it's not only governance at the end user layer, it's also governance at the modeling layer. So let's just do a couple more things. Let's hook up my product dimension. Now you see I have product hierarchy as well as subcategory attribute comes for free. And let's do some dates. So I have an order date. I also have shipping date. So I'm going to want to be able to report on those separately. So I'll go ahead and connect up order date. And now we're going to do role playing. So I'm going to give it a prefix of order and watch what happened. There's my order date hierarchy. And you can see that it inherited the hierarchy that you do that from that date dimension model. And I could do the same thing with my shipping date. I'll go ahead and do shipping, and voila, I now also can cut all my data by shipping date right there. Now we Design Center understands nested data. I happen to have key value pairs for my product attributes. I'm going to go ahead and express or pull out my color and style attributes. Those become virtual columns that you see here in my data set. And now I can go ahead and dimensionalize those. I don't have to call my ETL team to do this. All I need to do is just go ahead and plop it right in there. And now I have degenerate dimensions right off of that table without having to do any additional ETL. So here's my model. I got my preview. I'm pretty happy with what I got so far. So let's go ahead and let's make that consumable. So when we make it consumable, what we're doing is that we're actually pushing, basically, we were building an XML document. So we were just using that visual builder to build a map, and it's a multi-dimensional map. And then what's happening now is that we've just published that to the AtScale service, and the AtScale service now has a model called the Databricks Lakehouse store, which now can be consumed. So AtScale behind the scenes has created it created a graph model off of that dimensional data. Okay, so now that we've published the semantic model, what we're going to do now is that I'm going to switch my hats. And I'm going to switch my hat away from being a data steward, and now I'm going to play the role of a data consumer. So I'm going to log in as a data consumer. I'm going to pretend I'm Joe, and I'm going to do that because I want to show you what it looks like for row-level security with different users. So today I'm going to play two roles. I'm going to be Joe, and Joe loves to use Tableau. And I'm going to play David, myself, who likes to use Excel and Power BI. So you can see here's my semantic model. Like you saw in Design Center, you can see there is a Databricks Lakehouse. So there's our model. And then you can see here I have my metrics. I'm going to start with order quantity. So that's how many products were ordered. And then here's my product hierarchy, line, category, and name. You saw that before. And now what I'm doing is I'm looking at my products, and you can see that I have a bike store. We'll march on. Let's go and look at it by time and see what our orders are by time. You can see there's my hierarchy. I'll do it by order. So there's my year. I can drill from year to month to quarter to month and so on. All using simple drill down, because those drill down paths and those hierarchies are part of the semantic model. So everybody's going to be reporting on the same time. I can also do look at my data by customer location. So remember I put in that location filter. So if I look at by country, you can see that Joe has access to customers who are in outside of North America. Remember that because we'll come back to that later. And then finally, remember where you had our key value pairs, that nested data, like JSON, for example. We had it, we broke out color as a key value pair. But there's all my products by color. Simple as that. Okay, so let's pop over to my Windows environment. And I'm going to now copy my MDX endpoint here to the clipboard. And I'm going to log in. Let's do Excel first. So Excel, everybody has Excel on their desktop pretty much. And what I'm doing here is you can see I'm connecting using Excel's native capability. And you can see it's from Analysis Services. Why does it say Analysis Services? It's because the Analysis Services uses the MDX protocol. So I'm just using an AtScale endpoint here. That's the AtScale service. I'm going to use Windows authentication. And in my Windows environment, I'm logged in as Dave. And now I can go ahead and I can see all my different projects that I've created. And then there you can see my Databricks Lakehouse store. Now it appears as a cube within Excel. And I can go ahead and create a pivot report simply by clicking what I just did there. And you can see there's the Databricks Lakehouse store. And you can see there's my sales metrics, and there's my metrics I added in my model. There's order quantity. And then there's color, like you just saw me do in my Tableau query. And there you have it. This time, there's no data copies. The only data that's in Excel here is the data that is in the result set. And if I want to actually turn those into formulas, watch what happens. I can actually turn these and get rid of that pivot tables. Let's say I don't want to use a pivot table for exploring data. A lot of people like to. But if I'm in finance, for example, I may want to model this data where I want to take the multicolored products and the yellow products, and I want to add those together to come up with my own sort of range or my own sort of combination. And I've now done that, and these cells are all standalone. You see they're cube value functions? That means I can go ahead and build these into a model. And I can just simply do a hit refresh all or reopen the workbook and get brand new data, brand new refresh data from my Databricks Lakehouse. And I can all do that all instantaneously. There you go. There's my updated data. Now for Power BI is a very popular tool. I'm also going to connect with analysis services. And the Power BI integration with AtScale is actually, let's go ahead and copy that again, is actually through DAX because that's the native interface that Power BI likes to talk in. You can see I'm connecting live. I'm not doing an import because importing would require me to extract data and pull it off of the Lakehouse, which at that point now it's all kinds of bad. It's a risk. It's stale. It's limited because it's going to be limited to what I can, the amount of data that I can query. Because it has to be fit in memory. Instead, I'm going to go ahead and connect to my Databricks Lakehouse store that I just created, and I'm going to connect live with Power BI. You're also going to notice that I'm not remodeling the data here. So I didn't need to remodel data in Tableau. I didn't need to obviously do that in Excel, and I definitely don't have to do that here in my Lakehouse in my Power BI console here. So you remember we had our different geography dimensions. Well, remember we had that city dimension. So now I'm just go ahead and I just ran a query as David, and you can see David can see North America. That's why you only see Canada and the United States versus seeing the outside of Canada and the United States, outside of North America. So that's the experience for the BI user. And if I'm a data engineer, I can simply go and connect. In this case, I'll connect to my DB Visualizer tool. This is just a little JDBC tool, and you can see there's my Sales Insights Databricks project. And then if you look at here, and there's my Databricks Lakehouse as a table. So there's all my metrics and my dimensions. So if I'm a software developer who wants to use JDBC or ODBC, I can go ahead. Let's go back and pick out pick out my query here. You can see. Let's pick out this one. Let's see. Let's pick out this one right here. Okay, so there's a query that I ran against Tableau. So I'm going to go ahead and paste that query in. This is now as a logical query, and what I could do then, let's set the wrong one. Come back. I want to copy this query. Oh, that's my MDX query. I want a SQL query. Hold on. Let's go back and pick a SQL query here. There it is. And let's make that a SQL query. I can go ahead and run that. You can see that's a logical query there, and I'm going to get the answer back as a result set. And this is against my semantic layer. So you can see I just used a bunch of different protocols to access that data. Now, what did happen behind the scenes here? Well, I kind of gave you a preview here. You can see this is our query log, and you can see this is where we begin things as Joe. So that was the first query I ran in Tableau. And then you can see I ran some queries as David's. And as those queries in David's, you can see that some of them are MDX. That's the inbound query that AtScale captured, which is MDX. But you can see that it actually generated a Databricks SQL query. And you can see that AtScale actually substituted an aggregate table in place of that sales log table that was the original table. So you can see in this optimization column here, you can see that we ran queries and we automatically created aggregates against that brand new model that I just created. AtScale already learned how to optimize. And you can see that we ran that in those queries in under a second, 655 milliseconds. So AtScale got really smart and made these queries fast and optimized by creating Delta tables on the Delta Lake. And now AtScale is going to keep those Delta tables up to date with the source data. So that's a really quick tour of what a semantic layer looks like, just to sort of summarize it and bring it all home. A semantic layer with a Databricks Lakehouse, we like to call it a semantic lakehouse. And the value that you get there is that you can eliminate the need for introducing some other BI serving layer, whether that be data extracts in Tableau, whether it be data imports in Power BI. Forget about all that and leave data in your Databricks Lakehouse and query it live using a semantic layer. You can also deliver business-friendly, ready-to-use, analysis-ready data for a wide variety of users and all your personas, your business users, your data scientists, as well as your application developers. And you can also get rid of that crusty old cubing technology. No reason to build cubes anymore. You can run multi-dimensional analysis live on the Databricks Lakehouse without any data movement, without any additional serving layer. So with that, I want to thank you for listening to me today. And if you want to learn more about a semantic layer and semantic lakehouse, please come to www.atscale.com. We have great use cases, customer studies, and demos on our resources page on the site, and you can learn a lot more and contact us if you want to get a live demo. So thank you for listening.